All right. Let's start. So, hello everyone. Welcome to our technical interview preparation program for software engineers. This is our first meeting. So I just dropped the link to my presentation in the chat. So if you want, you can click on the link and you can get access to my presentation here. Okay. So I hope like your fall semester is going off to a good start. I think most of the students here, you guys attended the seminar. I think a few weeks ago, I think. So if you attended that seminar, or you took classes with me previously, you already know me. But I think there might be students who missed that seminar, but then directly sign up for our program. So please allow me to briefly introduce myself here. My name is Hao Yue, and I am associate professor and also associate chair of the computer science department at SF State. So I joined SF State back in 2015, and so it has been 9 years. Well, since I joined SF State, I have been teaching classes and also working on projects focusing on programming, data structure, algorithms. I actually have taught a variety of courses about programming and the data structure to various audience. For example, from K through 12 grade students to college students and to adults. Okay, and so I have also worked with a number of undergraduate students and graduate students on projects, and so and a lot of them actually got a job offer from high-tech companies like Amazon, like Google, like NVIDIA, Facebook when they graduate. And so I observe, and I was also involved in the process when they prepare for technical interviews for those positions, right? And I have also observed that a lot of students at SF State struggled with this process. I mean, preparing for technical interviews for software engineer jobs. So I decided to create this program to help more students to navigate this process and to support students to get to ace the technical interviews and get your job offer. So I started this, I actually piloted this program back in summer, late summer. And I think there were 10 or 12 students who joined my summer lectures. And so we had 8 lectures in total. So we met once per week for 1 hour, 30 minutes. And so at the end, we together, we practiced about, I think, 30 technical interview questions on LeetCode together. So well, 8 lectures, 90 minutes, for each lecture. So it was about 12 hours. And of course, like students, they spend some time after the lecture, but I would say like, it is pretty good. Like, you spend about 20 hours and you complete like 30 questions on LeetCode. So I got positive feedback from students back in summer. So I decided to offer this program again in fall, but hopefully can reach out to more students. That was the reason why I invite students to join the seminar, and now we are here, right? We are here. So next I want to just briefly talk about what this program can offer to students like you who participate, right? So we are going to have Zoom lectures or Zoom meetings twice per week, and so on Tuesdays and Thursdays. And so in those Zoom lectures, we are going to cover different topics on data structure and algorithms for technical interviews. So usually we spend 1 or 2 lectures on one topic, and also during those Zoom lectures, we will go through some examples or a sample technical interview questions together, right? And then I know like some students, they couldn't attend those Zoom lectures, but they still want to stay in this program. And as I wrote in my email, I'm also going to create a website for this program where as long as you sign up, and you will have access to the resources posted or shared on that website. So I do plan to share lecture videos and my lecture notes, and also some other materials such as the solutions for interview questions on LeetCode on our program website, right? I'm going to share the. So right now I'm building that website. It takes me some time, and so I'm going to share the link to every of you as soon as it is ready. Okay. So I also hope that we can together build a learning community when you stay in this program and prepare for your job interviews. So as some of you know that preparing for technical interviews for software engineer jobs is not easy. It is not easy. It takes time, it takes efforts, and you have to be persistent. You have to be confident. So I feel like a community where all of us can significantly support each other, and we can also help each other with their questions when we are all in a community, right? So I plan to create a platform, could be a Discord channel, for example, where we can communicate, and we can help each other with questions and share resources, for example, on that community platform. And I'm going to share that with you sometime this week, I would say. Okay. So those are the goals of our program, and I'm not going to read through them because I actually went through them back in the seminar. So, but again, my goals are to help everybody. First of all, create a plan when you prepare for the technical interviews. A plan is very important, trust me. So then I hope like the lecture notes and the resources can help you enhance your understanding on data structures and algorithms. And so, of course, we are going to solve some technical interview questions on LeetCode together. And hopefully, through all of those efforts, you will be more confident, and you can persistent when you prepare for your job interview, because this, again, is not easy, and it often takes you a couple of months. So you have to be persistent, and you must be confident so you can survive, navigate and survive. I just want to repeat some basic information about this program for this fall. So we are going to have Zoom meetings on Tuesdays and Thursdays. So from 2:30 to 4 p.m. All the lectures going to be on Zoom, and I do recommend that you have already complete CSE 220, so you have some basic understanding about data structures and some algorithms. Otherwise, you may need more time to first, learn those materials before you come to the lecture. So then the lecture material is going to be more efficient for you to prepare for the interviews. All right. So the last thing I just want to briefly mention is that, well, if you have already known me, or you have, you took my classes previously, you know my teaching style in classrooms, right? So I am an expert on pedagogy in computer science, and in my classrooms, I often use a variety of engaging activities to engage and our students. But this program, I think, is different because, as you will see, there are a lot of topics and content to cover, and so I want to let you know that most of the time it will be me present or talk here. So I do understand, like, small group discussions or some engaging activities can keep you concentrate, and but I also hope you understand, like, this will take a lot of time, right? If this is like a semester long course at our department, we can definitely do that. But for this one, I just feel like, everyone's time is very precious, and I know some of you have part-time jobs and you need to take other classes, right? So I just want to make sure, like, when you stay here, when you join our Zoom meetings, you can learn as much as you can, within that 1 hour 30 minutes, right? So I hope you understand. But if you have concerns, or you want to talk about that, feel free to let me know. All right. So, but I want to be transparent and clear about this. The last one I want to be clear is this disclaimer, and I share it with students in the seminar, but I want to repeat here in case any of you missed that. So this program is my personal initiative. So it is not affiliated with or endorsed by the CS department or SF State, right? This is my personal thing. And so if you have any question or any concern, please contact me directly, and you can find the official email to this program here, right? So please do not complain to the department or to SF State, because again, this is my personal initiative. I want to be clear about this, right? Okay, so I spent 15 minutes. That's good. That's good. So before we go to today's technical content, does anyone have any question here? Now, feel free to either speak or drop a message in the chat. I just want to make sure, no matter whether you attended that seminar or not, now we're on the same page about this program. All right. Sounds good. Thank you. Okay, so in this very first lecture, we are going to talk about arrays. So what is an array? What is an array here? Well, array is a data structure that holds a fixed number of values of a single type. Well, in this program, we are going to use Java as our primary programming language, because in our computer science program at SF State, we use Java for our introductory programming courses, right? Like CSE. Well, previously we called it CSE 210, but now it's CSE 215, I think, or whatever, and the CSE 220, right? So in Java, all the elements in an array, they must be a single type, right? But this may not be the case in other programming languages. For example, if you are familiar with Python, and like in Python, we have a data structure called a list, right? So in that data structure, the values, the elements could be different types, But here, we say all the values, they must be the single type in Java. Okay, so this is the definition of an array here in Java. So I want to draw your attention. So first of all, array, every time when we create an array, the array holds a fixed number of values, which means, we count. So once we create an array, so the size of the array is decided, right? And the second thing is all the elements must be a single type. Okay, so here is an example in Java about how we can create a new array here, right? So for example, this statement will create a new array where all the elements are integer numbers, right? So as you can see here, we use a keyword called new, and here 5 actually specify the size of this integer array, right? And so there are 5 slots, or in this array, and we assign this array to a variable, and it is called ARR, as stands for array. Okay, in this example. So now, when we execute this statement, what happened? What happened when we execute this statement? So a couple of things actually happened when we run this statement. The first one is the program language, or the compiler, or the computer, right? Allocate a contiguous memory of size 5 times the size of each element. Well, in this example, all the elements are integers, right? So int, the data type. So the computer or the compiler will allocate a contiguous memory of size 5 times the size of one integer number to this array. So so this memory can hold 5 integer numbers, right? Can hold 5 integer numbers. And every time when we create a new array, all the elements in this array are set to be the default value, right? For example, for integer, all the elements, the default value is 0. So all the elements going to be set to 0, right? And then this variable, in this example, ARR, will store the base address of the memory space. So here, what do we mean by base address, right? Base address. Well, if you have already complete lower division courses like 215 and machine structure, so you should know, right, the address of the memory space, right? The address of the memory space. So all the storage units in the memory space, they are associated with address, right? So in this example, we can see the address of the first element in this array, we assume it is 100. And then the address of the second element in this array is 104. Why this is 104 is because in Java, the size of an integer number is 4 bytes, right? So we use 4 bytes to represent integer numbers. So if the first element is address is 100, then the second element is address should be 100 plus 4, which is 104. Okay, so then the address of the the third element is going to be 108, so which is 100 plus 4 plus 4, right? And so on and so forth, and so on and so forth. And then this variable ARR actually stores the base address. In this example, the base address is 100, which is the address of the first element. So ARR stores this address, which is 100. And so then, if we want, we can access an element in the array by using its index. For example, if we want to access the first element in this array, which is we can use ARR 0. 0 is the index. So in array, the elements can be accessed by integer indexes, and the indexes begin from 0. So the first element its index is 0, second element index is 1, and so on and so forth. So what happened when we access an element with their index is like, when we, let me get my pen here. So for example, when we want to access ARR1, when we want to access this element, and when we use ARR1, what happened is, Java will first access a variable ARR, and don't forget that ARR stores the base address, which is 100, right? Okay. And then the index here is 1, all right? So then we will calculate the address of this element by saying 100, which is a base address, plus 1 times 4, okay? Here, 1 is the index, and 4 is, again, the size of one integer element. In this way, we can get 104, which is the address of the corresponding element. So then we are able to access this element in the memory. So hopefully from this example, you can also tell why the index of the first element is 0 in the array. Because when it is 0, we do 100. When we want to access this element, we calculate 100 plus 0 times 4, which is 100, right? So this is why in arrays, the indices begin from 0, but not from 1. Okay, so I think you have already learned those basic things from the lower division programming classes. So, but just want to spend some time, refresh your memory, make sure you understand those basics about arrays. Okay. All right, next, let's look at the basic operations on arrays. So those operations are fundamental, and in fact, later we are going to look at other topics, for example, algorithms on arrays, and you will see like actually those algorithms will use these basic operations very frequently. So understanding the basic operations is the key to understand those algorithms and also understand their time complexity. Okay, so we will spend some time first look at the basic operations on arrays. All right, the first operation is access an element at a given index. So for example, let's say now we have an array here, and like the array I showed you previously, right? And then let's say now we want to access and print the second element in this array, right? How can we do that? I believe all of you know how to do this, right? In Java, we can say system.out.print, and we use the index to access the element, right? So the if we want to print the second element, the index is 1, so we say ARR1, right? Okay, then what is the time complexity for this operation? So all right, I assume you have already. I assume you are familiar with time complexity big O notation, which is a topic I think, or I hope, covered in our introductory programming or data structure classes, right? So if you are not familiar with this topic, you can find a lot of resources online and talking about this. And so I'm not going to spend time to review time complexity here, but just assume like you already understand the basics. Okay. All right. So the time complexity for this operation going to be big O1. I think everybody agree on this, right? So we just access we directly access the element, there's no loop, nothing, so it's big O1, right? Okay, this is how we can access an element at a given index in an array. So the second operation we are going to look at is update, or we say we change an element at a given index, right? So this happens very common, right? So when we have an array, and then we probably want to change or update the value of an element at a given index, right? How can we do that? This is also very easy. So in order to change the value of an element in the array, so we access that element by using its index, and we simply assign a new value to that element, right? So in this way, the old value will be replaced by the new value, right? Now, for example, let's say now we want to change the value of the second element in this array to be integer 5, and so we can use ARR1. We assign 5 to this element, and we update its value. Right. Okay, then what is the time complexity for this operation? Is also big O1, right? So we access the element, we update its value, that's it. So it's also big O1. Okay, all right. So I want to pause here for a few seconds. Does anyone have any question about those two basic operations? Any question here? Everybody is okay? Okay, good. So now I would like to give you guys an exercise. So I'm going to drop the link in the chat. All right, so let me briefly explain this exercise a little bit before you work on that, okay? So I'm going to see if I can enlarge my window a little bit. So throughout this program, we are going to use this website. It's called Trinket. When we need to write, when I want to give you some programming exercise. So I have been using Trinket for a number of years, and I really enjoy this say platform. And so the good thing about it is, like, I can create a programming window with the coding exercise, and then I can share the link with you, and then you can directly work on that. You can directly write your code there. You don't need to register, and you can write your code. You can run your code. Okay, so let me briefly explain how you can write your code and run your code here. As you can see here, this is a coding practice in Java, and so you can write your code in the left-hand side window, which is here, right? So as you can see, I provide some starter code, and I want you to, for this one, I want you to complete the code so we can replace all occurrence of integer 1 in this array. In this given array with integer 0. And so I want you, so your program should operate in place, which means you modify the input array without creating a new array, right? So I provide some starter code, and then you can just write your code here. So for example, you can say print whatever, and so you can just write your code, okay? And when you are done, you can click on this run button and run your code, and then the console is on the right-hand side. Of course, right now the code is incomplete, so when we run it, we see an error message, right? So super easy, right? So you write your code on the left-hand side, you run it, you can see the result on the right-hand side. Okay, so because you do not have an account on Trinket and you don't subscribe, so the limitation here is you can't save your program. You can't save your program onto Trinket. I think you can probably, I think you can download your program to your computer, but you will not be able to save any change online on this website. Okay, so now I hope like every of you now is on Trinket on this program window. So if you don't have any question, I'm going to give you a few minutes, see if you can um, solve this coding practice by using what we have learned, I mean, the basic operations on arrays. Okay. Once you are done, give me a hands up, maybe just drop a quick message in the chat so I know, like, how many students have completed. So we will go to the next part. All right. Okay. Anyone um, who has solved or finished this problem, feel free to let me know. If you have any trouble opening the Trinket link, also let me know. Okay. Great, thank you for letting me know, Christian. Good job. Anyone else has already completed this one? If you have already finished, think about the question at the bottom of the problem. What is the worst case time complexity of your code? Worst case time complexity. When the input array, the size of the input array is n, let's say, right? When can I access the recording of your video? Before I try to build the website for our program sometime this week. So, but before that, what I can do is I can send everybody the recording through emails after each lecture. So, which means I can probably send you the recording tonight when it's ready. I hope I answered your question, Ronak. All right, so final check. And has anyone has anyone else finished this exercise, or do you need more time? Let me know. Okay. You guys are so quiet. I hope you are. Okay, maybe you are still working on this. All right. Okay, so I'm going to share my screen here, and let's look at this exercise together, right? So, as you can see, I just add a for loop here, and where I try to print out each element in this array, right? So again, we have seen an example like this. When we want to access an element, we can use the name of the array and the index, right? So for loop is we simply just loop over all the elements in this array, and so we print out each of them, right? So pay attention to this for loop, and where I use the variable I here, I begins from 0, which is the first index. And here, I hope you are familiar with this one, right? So this is the length of this array, right? So when we create this array, we say the size is 5. So actually this is 5, but I prefer to use this variable here. And every time we just move to the next element, so I++, a very common way for using for loop to loop over all the elements in this array. So if I run my code here, and as you can see, I can print out all the elements in the original array, right? Okay, now the question is to ask us to replace all occurrence of integer 1 in this array to integer zeros. So of course, like I don't want you to simply just modify those ones manually to zeros, and that is not what we want, right? So given an array, we want to replace integer 1s to integer zeros. So what we need to do is we need to loop over all the elements in this array. As for each element, if it is equal to 1, we update its value or change its value to 0. Okay, so how can we loop over all the elements in this array? So we need a for loop, right? So we need a for loop. Okay, then in this for loop, inside this for loop, for every element, if it is equal to 1, we update its value to be 0. So if this element is equal to 1, we have to replace its value to be 0. And again, we have seen examples about how to update or change the value of an element in the array, right? This is how we do that. We simply just assign a new value. All right, okay, and then I think we are done. See? So we replace all the occurrence of integer 1 to 0. Of course, there are other ways to write this program. For example, you can combine those two for loops just into one for loop, I believe. And so you can do that, but this is one way to solve this problem, right? Okay, does anyone have any question about this? All right, then what is the worst case time complexity? Well, so for this algorithm, right? So we will have best case time complexity, and but usually we focus more on the worst case time complexity because that will tell us, you know, the worst thing we can expect, right? So that is like, you know, like the bottom line, you know. So what is the worst case time complexity for our code or algorithm, right? Yeah, yeah. I think you guys, some of you have already answered that in the chat. I appreciate your participation. So the worst case time complexity should be big O. Yeah, big O n, right? Okay, so when answering this question, some students say it's big O n. Why? Because there's a for loop. There's a for loop, so it's big O n. Well, if you answer in this way, this is not 100% correct. Well, we will see some examples later where there is for loop, but it is not big O n, right? So a better answer should be it is big O n because in the worst case, now what is the worst case, right? In the worst case is all the elements in this array are ones, which means, you know, we will have to update each element in this array, and that update operation complexity is big O1. So big O1 times n for n elements, it is big O n. Right? So this is a better answer in the technical interview. Make sure your answer is accurate and precise. Right. Okay, so now let's go back to the slide presentation. All right, so well, again, if you have any question, feel free to drop a message in the chat at any time, and I will answer it. I will try my best to answer it, you know, instantly when I see it. Okay. Okay. Now let's look at the next operation, basic operation, which is add an element to the array. So this is also quite common, right? So when we have an array, we may have some new elements, and then we want to add those elements to our array. So we can store those elements there, right? Okay, so there are actually two common scenarios when we want to add a new element to a given array. The first one is we want to append this new element to the end of the array, right? So we just want to put it to the end of the array. Well, in fact, even this case could be very complicated, right? For example, when we want to add a new element to the end of a given array, but the array is already full, which means there is no available space at the end of this array, right? And then in this case, what we have to do is we will have to we say like resize the array by first adding more space to this array, right? And in Java, there are ways for doing that, okay? But we will not focus on that here. So here we simply assume that the array is not full, which means, well, when we want to append the new element to the end of the array, there is space. There is space, so we can do that. We don't need to worry about resizing this array by adding more space. We don't need to worry about that. Okay. Then, in this case, it is very simple. It is very simple. So what we need to do is we just assign this new element to the end of the array, right? So for example, if in our program, we use a variable called length to keep track of the number of current elements in this array before we add this new element, right? So here I use length instead of arr.length. Is that for example, when we create an array and the size of the array is 5, and then arr.length is equal to 5, right? But let's say we only store 4 elements in this array, and so in this case, this variable length is going to be equal to 4. So as you can see, we can't use arr.length here, because if we use that, you can imagine what's going to happen. We will get an error message that will exceed the boundary, right? So here we assume we have a separate variable. It's called a length, just to keep track of, the number of elements in this array. So length may not be equal to arr.length, right? I hope you understand this one, right? So then when we want to just append a new element to the end of this array, we can just say arr length, equals to 5. So we assign 5 to the end of the array. Okay, and the time complexity for this operation is big O 1 because we access one element, we assign a value to that element. It is big O 1. Big O 1. Okay. Does anyone have any question about this operation or this example? So we can maybe let me draw an example here. Will help you understand. Right. So let's say we have an array we call it ARR, and when we create this array, the size is 5, like this one, right? There are 5 slots. So if we say arr.length, this will always be 5, right? This will always be 5. But when we store values in this array, right, we may not use all the slots. For example, we could do something like 0, 1, and 2, right? We only store 3 values, and so those 2 slots are available, or we call them empty. Now in this case, we say we can use another variable called length, simply just to keep track of the number of elements in this array. So in this case, length is going to be equal to 3, right? Because there are only 3 elements. Now, when we want to append a new element to the end of this array, for example, now we want to add a new element 5 to the end of this array. How can we do that, right? So we can say ARR. Now, what is the index of this slot? So this is 0, this is 1, this is 2, this is 3, right? I'm talking about index. Index. This should be 3, which is actually length. So we just say length. And then we want to assign 5 to it. So this one should be equal to 5. Right? Okay. 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 Now let's look at another scenario for adding a new element. So this time, let's say we want to insert an element to the beginning or the middle of the array. For example, given an array here, we call it nums. And let's say we want to insert 2 to the third position in this array, which is here, right? So this is a third position. We want to insert 2 to this position in this array. How can we do that? How can we do that? So I hope you can see from this example here, like we can't simply just assign 2 to this slot. Because in this way, this value 3 is going to be deleted or overwritten, right? So in order to insert 2 to this position, first we have to make space or make some room for this new element by moving or shifting all these 3 elements 1 slot to the right. Right. So when inserting an element at the beginning or middle, we need to move all elements at and after this position 1 slot to the right. In this example, we have to move this element, and this element 1 slot to the right. So we can make space for the new element 2. Now, I'm going to show you an animation about this, right? So first, we have to move the last element to the next slot. Then is this element 4, and then is element 3. So then we actually make some room for this new element, so we can simply assign this element to this, to the third position, right? And we are done. We are done. So when we want to insert the element at the beginning or the middle of an array, we need to move all elements at or after this position 1 slot to the right. Then what is the worst case time complexity then? Right? So this time complexity is going to be big O n. Why? Because in the worst case, we will want to add or insert a new element to the beginning of this array. So then we have to first move all the elements in this array 1 slot to the right. And the complexity is going to be big O n. And as for each element, moving this element to the next slot will take big O1 time, which is a constant time, right? So because we have to move all the elements to the next slot, so big O1 times n, which is big O1. Big O1. Okay. Does anyone have any question about this operation? Okay, if not, now it's your turn. And let's look at another exercise. So in this exercise, as you can see, I provide the starter code, and I want you to add some code here so we can insert this new element to the third position, which is actually the same as the example, but now I want you to write some code to implement it. I'm going to give you a couple of minutes to see if you can, write the code by yourself or not. Okay. Some students have already finished this one, and what about others? Have you finished it? Okay, great. Some students drop a message and share that they have already finished. And if you haven't finished this one, don't worry, and um, you can continue after the lecture. And I also want to share with you, actually, don't be frustrated or upset if you say, hey, I couldn't complete the exercise or coding challenge in 5 minutes or 10 minutes or 15 minutes. Again, well, usually when people prepare for technical interviews, they will have to go through multiple rounds. Usually in the first round, especially if you do not have any, if you have never prepared for technical interviews previously, the first round, your expectation should not be like, okay, I should be able to finish all the questions in a reasonable amount of time. No. Only very few people can do that, frankly speaking. So in your first round, just to make sure you understand the content. You know how to solve the problem, although you may not be so familiar, which means you may not be able to write the answer in, let's say, 5 minutes or 10 minutes, right? But that is what you may want to practice, right? So for example, after this class, I do encourage you to practice those exercises a couple of more times, right? Make sure you are familiar with the code, you understand, and you can then, you can finish in less time. That is what you can do. Okay. All right. So let's look at this one together. So even for this exercise, there are actually 1 or 2 places you want to pay attention. Otherwise, you will get errors. Okay. So in my lectures, when I explain the code for a coding problem, what I'm going to do is I'm going to accompany the code with a live example. Okay, so a lot of people, when they explain the solution, they simply just show the code and then read the code with students line by line. But I don't think that is very efficient, because if students cannot see the example, and especially when they don't understand how it works, right? You read through the code is not efficient. So what I'm going to do is I'm going to show you the example, but then I will also accompany with the code, and you will see how we write that code from that example. Okay, so hopefully this will help you. So okay, let's look at an example. Let's say this is a given array, we call it nums, and we want to insert integer 2 to the third position, right? So what I'm going to do here is, like, instead of using 2 in my code, I'm going to use a variable called insert index. And so for this particular example, it should be equal to 2, right? But like I want to use this variable to make my code more formal. So, and again, remember, previously I told, we can use a variable to keep track of the current length of the array, right? So as you can see in this array, actually, the size of this array is 6, right? When we create this array, there are 6 slots, but there are only 5 elements at this moment. So I use the variable length, which is equal to 5, to keep track of the number of elements in this array, right? So, and yeah, remember, when we want to insert an element at the beginning or middle of the array, we need to move all the elements at and after this position one slot to the right. And so let's see how it goes, right? So we will have to begin from the last element, right? We will have to begin from the last element. In this example, we have to begin with the last element, which is equal to 5. So we move 5 one slot to the right. So here, I'm going to use another variable. Actually, we often call it a pointer, right? Point to the end of, point to the last element. Point to the last element. Actually, I think no, there. I think here is a mistake. So it should be. Oh yeah, that's right. That's right. So let me show. Yeah. So I'm going to use this pointer. I call it J, and right now J points to the the slot where the destination slot where I gonna move the last element, which is 5, right? So here, if we make J equals to length, now the pointer J will point to the destination slot for the last element, which is 5, which is the index of 5. Okay, then we move the last element 5 to one slot to the right, and then next step is to move element 4 to the next slot. So here, what we can do is we can move the pointer J. So now J points to the destination slot for element 4. And we repeat, right? So now J points to the destination slot for element 3. Well, when this array is pretty long, of course we don't want to do it manually, one element at a time. So we can use a for loop or a while loop. We can use a loop, right? So here I use a while loop, right? I use a while. As we can see, we should stop when J is here. So we should stop when J is here. So now J is in fact equal to insert index plus 1. Right? In other words, now while J is larger than index insert index, we should repeat. So we move an element to the right, one slot to the right. How can we do that? We can use this one, right? Nums J is equal to nums J minus 1. So basically, we assign the value in nums J minus 1 to nums J. So basically, we move the element one slot to the right. And don't forget that after each movement, we have to also shift J one slot to the left. So basically, we can use J minus minus. So then we can move the next element, right? So if you want to see it one more time, we begin from here when J points to the destination slot for the last element. And then we simply just repeat every time we move the element one slot to the right by assigning its value to the next slot or next element. After that, we move J one slot to the left. So by J minus minus, right? Okay, after all of this, now we can add new element 2 to this position. So nums insert index is equal to 2. Right? I think I forgot some semicolon here, but I think you got this idea. Okay. All right. Does anyone have any question about this code? I don't have time to run this code on Chinkit, but you can do that after our meeting. And I apologize, I missed some semicolon here, and don't forget those semicolons when you run your code. Okay, so the last operation I want to show you in this meeting is delete an element in an array. And there are also two scenarios. The first one is we want to delete the last element in this array, right? So in fact, there is no function or no command here say we can, permanently remove, the last elements in the array, right? So, but what we can do, or what we often do in this case, when we want to delete the last element is, again, if we use a variable length to keep track of the number of elements in this array, right? Now, what we can do is we simply just reduce this variable by 1, meaning that, now the last element is no longer part of the array. Right? Okay, I hope this is easy to understand. So we simply just reduce the variable length by 1. So the last element will not be considered, will not be included in this case, right? And of course, the time complexity for this operation is big O 1. Very simple. Okay. The trickier scenario is actually we want to delete an element at the beginning or middle of the array. Now you have seen the add operation when we want to add or insert element at the beginning or the middle. Now you probably can imagine that, right? When we want to delete an element at the beginning or the middle, we also need to move elements. Now, for example, given an array like this one, if we want to delete the third element in this array nums, how can we do that, right? So let's say, okay, we delete this element, but we're not done yet, right? Because now there is an available, or we say empty slot. So we will have to move all the elements after this element 1 slot to the left. Right? Remember, all the elements in this array, they are stored in contiguous memory space. We can't say, well, this one, there is like a gap in this array. We can't do that, right? So after we delete an element at the beginning or the middle of the array, we will have to move all the elements after this element 1 slot to the left. So here is an example, right? So after we delete the third element, now we will have to move the next element, which is 3, 1 slot to the left. After that, we move element 4, 1 slot to the left, and then we move slot 5, 1 slot to the left. And of course, if we want, we can also update the variable called length. Now, previously there are 6 elements, right? But now there are 5 elements. So we just reduced it by 1. So we say, okay, now there are 5 elements in this array, meaning that the last slot in this array is, is empty or things like that. Right? Okay, does anyone have any question about this example here? All right, so let's summarize. When we want to delete an element at the beginning or the middle of the array, we need to move all the elements after this element 1 slot to the left, right? And so comparing to the previous operation, when we insert a new element at the beginning or middle of the array, we know that the time complexity for this deleting operation is also big O n. Because in the worst case, if we want to delete the first element in the array, we will have to move all the remaining elements 1 slot to the left, right? And the time complexity for moving 1 element is going to be big O 1, and there are n elements, so big O n. Worst case time complexity. Okay, so now I'm going to give you the last exercise for today's class. I drop it in the chat. So in this exercise, I want you to add some code so we can delete the third element in this array. So try to implement the deletion operation here. Okay, so there are 10 minutes left. So I'm going to give you guys about 5 minutes, and then I'm going to go through the code here with you, and then we are done for today. Okay. So I'm going to grab some water, and I will be back in 1 or 2 minutes. Okay, I know some students may have class after this meeting, so let's stop here. And again, if you haven't finished, you can continue after this lecture. Okay. All right. So let's look at this example, and I will also show you how to come up with or how to design the code here. So let's say we want to delete the third element in this given array called nums, right? So I'm going to use this variable called delete index here. To refer to this position, and in this example, it is equal to 2, right? And we have also know that when we want to delete an element at the beginning or middle of the array, we need to move all the elements after this element one slot to the left. Let's see how we can do that. So we know we will have to repeat the action, which is we move one element to the left, right? We are going to repeat this action for all the elements after delete index. So here I'm going to, as you can see, I use a pointer. I call it j. And so j will begin from the next element after delete index, which is this one, right? And so j is equal to delete index plus 1. And all the way to the end of this array, right? All the way to the end of this array. And well, in this example, as you can see, we assume that this array is already full, right? This array is already full. So in this case, we can use nums length, right? We can use nums length. But if the array is not full, what we can do is, like previous example, we can use another variable length, and keep track of the number of elements. And in that case, we have to replace nums length with length, right? I just want to be clear about this one. In this example, because the array is full, or we know it is full, we can use nums length. All right, now the action that we repeat is for every element, right? We move it one slot to the left. How can we do that, right? Nums j minus 1 is equal to nums j. So basically, we copy the value of one element to its previous element, or previous slot, or previous position. And after that, we have to increase j by 1, so j will point to the next element we want to move, j plus plus, right? So it will look like this, right? Okay, and we first move 3, we move 4, we move 5, and then we're done, right? Okay, does anyone have any question about the code here? So I think I will have to, I will have to modify, So in this slide, I use I instead of delete index. I apologize, should be consistent, and I will modify them after this meeting. So, yeah. All right, so some of you may wonder, so are we going to look at any real technical interview questions today? So we don't have time for that, but after you learn those basic operations, actually, well, as you can see, those are actually very basic operations. Some of you may already know them, and so bear with me. I want to spend the first lecture cover those operations. Just want to make sure all the students have the foundation to practice and solve the technical interview questions, right? So now, once you understand those basic operations, actually you can try this real technical interview questions, which is question number 27 on LeetCode. I'm going to spend 1 or 2 minutes explaining what LeetCode is, but if you are already very familiar with LeetCode, okay, you don't have to you don't have to stay for that part. But like, you can try this question on LeetCode. And well, I want to be clear. So there are different ways for solving this problem on LeetCode. So I'm going to show you a very efficient way in 1 or 2 lectures. But for now, you can actually try to use those basic operations to solve this problem. You can still pass the test, right? So in this question, you are asked to, you are given an integer array and also an integer called a val. You are asked to remove all occurrence of val in this array in place, right? So we have already learned how to remove one element in the array. Now, what you need to do to solve this problem is you have to use another loop to loop over all the elements in this array. And then if it is equal to val, you remove it, right? You remove it, okay? So after today's class, you can try this problem on LeetCode. And then in our next lecture, we are going to look at this, we are going to look at a solution together. Again, this will not be the most efficient solution, but it is a good one for you to understand those basic operations. Okay. So yeah, somebody I think also mentioned that in the chat. Yes, I agree. So there's better solutions. There are better solutions, but for now, you can try those basic. You can try the suboptimal solution, but this can help you better understand those basic operations, right? Okay, so now I just want to quickly go through LeetCode very briefly. And so, okay, so when I spent one summer at Google back in 2019, I joined a program called the Faculty Residence Program there, where I met HR, I met recruiter, I met engineers. We talk about how to better prepare our students for technical interviews, especially students from universities like SF State and many other universities with limited resources. So Google's recruiter and Google's engineer recommend LeetCode as the online platform for students to practice technical interview questions, right? Again, you know that when you in technical interviews, you are often asked to write code to solve one or two computing problems, right? And I think LeetCode appeared, I can't remember, maybe many years ago, first as a forum where people who interviewed by those high-tech companies, they share the interview questions on this forum. And gradually somebody, take the lead and kind of like, trim those questions and, maintain like a list of questions that are often tested by high-tech companies. And so then we have LeetCode. So once you log in, and you can see there's one tab called problems. You just go there, and so you will be able to. Oh, my network is a little bit slow. Bear with me. And then you can see a list of sample technical interview questions, and here. And right now, I think there are more than 3,000 questions on LeetCode. So I think it's enough for people to practice, right? And you can filter by difficulty, you can filter by topics, things like that. And so yeah, and let's maybe go to question number 27. It's the one I gave you. So you click on that, and you can see, well, there are a couple of windows here, right? So on the left-hand side, you can see this is a description of the problem, right? And then you can write your code here. And of course, you can choose the program language you want, right? So we use Java. And once you complete, you can first run your code. When you say run, your code will be tested by a few test cases. Only a few test cases. If you pass those test cases, you will see accepted. As you can see, there are only 2 test cases, right? But this doesn't mean your code is 100% correct. This only means like your code passed 2 test cases. So then what you can do is you can click on submit. Now, when you click on submit, your code is going to be thoroughly examined by a lot of test cases to see if it is correct or not. If it is correct, you will see accepted. That means your code is good. You solve this problem. Congratulations. If not, you will see error message here. You will see some error message here, which means you have to debug your code. All right. And yeah, those are the basic functions or features we will need, when we write code and practice on LeetCode. Of course, there are many different features. For example, if you want to see solutions from others, you can click on this one. People post and contribute many different solutions. And if you want, you can also buy the premium membership. There are some additional features, but for our program, those basic features, I think are sufficient. Okay, so then what I'm going to offer is that I'm going to categorize problems on LeetCode into based on the topics, right? So and then I'm going to also share with you templates where you can use to solve all the problems under the same topic. So you don't have to just go to LeetCode and randomly pick a problem and solve it. This will take you a lot of time. Okay, but this is how you can use the LeetCode in case you are not very familiar with it. And again, after today's class, try problem 27. See if you can solve it or not by yourself. And I'm going to show you a better or more efficient solution in a few lectures. Okay, guys, this is all for today's meeting. I hope you like it. And again, the content the content we cover in this lecture may be slow, maybe basic. Just want to make sure everybody is on the same page, and we are going to learn some advanced topic very soon. Okay, and I hope you like it. If you have any feedback, comments, feel free to let me know, and I will see you guys on Thursday. Thank you very much. Have a good one. Bye bye.